It doesn't matter. That's just not okay.
So was I last.
Why are you reading text out loud? I hate people that like Facebook conversation. We did this and they read the whole thing out like no one cares.
No. Oh my
Sorry.
God. Again with the stop.
I'm kind
Stop.
of that was kind of really me. Like I just get annoyed by it. But
really?
continue.
Okay.
You do you.
Majority of the stuff that comes out
No,
of
no,
your
no,
mouth
no, no.
is that.
It's not a judgment on you. It's a judgment on me because I have no patience and I should have more patience. I really should.
Yes, you really should.
See,
You
this
need
is
to work
the
on that.
Scrooge coming out.
Patience is a virtue.
Sorry.
Okay, this is you like 77%.
All right, so let's do this because that is recording as long as this thing didn't get pulled out.
No, we're good.
And this is recording now and it's got a charge. Yes? Okay,
Again, the
excellent.
pizza box.
Because it holds it up. Because otherwise, without the case, it doesn't sit on there, right? I have to take it out of the case to charge it, right? So it doesn't attach to this because the top is just a little screw mechanism, and the screw mechanism only works with the case. So this works as a platform. Okay, so let's solve this. Pull up my rules, okay, of tips and tricks for things, okay? Tips and tricks for the trig functions, the proofs. Pull those up. Good, okay. This is just like trying to get you guys to look at the notes in class. I wait 5 minutes before starting class. You still haven't pulled them up, so eventually I just start. All right, so this stuff.
Oh my
This
God.
looks more complicated. That was great. This looks more complicated.
Real lady like, oh, okay.
This looks more complicated, so we're going to start on the more complicated side. Are we ready for this? Because I'm doing this for you guys, and if I'm just talking to myself, why am I here? Or if I'm just talking to Cece, why am I here? Okay.
You realize that we're going on 3 hours, right?
I know that, but
I know.
either we go home and don't do this, or we sit here and we do it, and I just do it for myself, right?
Go for it.
I'd rather just go home.
We're here.
So, okay, so
With you.
this is more complicated, so we're going to work with this side, try to get it to look like that. Get it in terms of sine and cosine is what I would suggest, right? So 1 we'll leave alone. I'll do that in black. But we're going to mess with tangent. So 1 plus, what is tangent the same as? I know it's tangent squared. Sine over cosine, right? Do we see why that is?
Sine squared over.
Quotient ID, right? And you know that because it's y over x for tangent, right? Which is sine over cosine. Yes?
Yes.
Haji.
So it's sine squared, because this is squared, this is going to be squared, over cosine squared x. Cool. Minus, we're going to leave that alone. Secant squared. How do we get that into terms of sine and cosine?
1 over cosine
Common denominators.
Common denominators. We can add, we can subtract, that's kind of cool. So let's do that. 1 from before plus sine squared x minus 1 is just sine squared x minus 1 all over the common denominator of cosine squared x. Do we understand why I didn't add these two together and get cosine squared x minus cosine squared x?
Yes.
It's common denominators, just like 2/3 minus 1/3. It's not 3 minus 3 is 0, right? That's not how we do things. Cool. So we get this. Interesting. Is it helpful? I don't know. We want to get here.
Can you no. How do you get it?
Boys and girls, this is option 1 that you might try because you're moving things around. There are ways to get from here to here. However, this isn't the quickest path. You can keep doing the algebra and figure all this stuff out, make this into common denominators over here and try to add together and then do things. Or you could have done this. Again, multiple ways to get the same answer. This is what I would suggest. Whenever you have squares, see if your Pythagorean theorem ID works first. Look at Pythagorean theorem IDs. Pythagorean IDs. Do we have anything that has tangent squared and secant squared in it? We do. 1 plus tangent squared theta equals secant squared theta. Let's write that out. 1 plus tangent squared theta equals secant squared theta. We've got this.
So
We could substitute this for secant squared theta, right? Oh, no, we can't. Yeah, we can. Yeah, we can. We can substitute that. You want to do that? Or you could see that, look. This is the same thing as moving this over here. This is an equation. We can move things around. Subtract secant squared from this side. All of this equals 0. And we could do it either way. Either you could see that and move it, or you could have substituted. Let's substitute 1 tangent squared theta with secant squared theta. So we're going to take this. Are you here? We're going to take this, and we're going to put that in there. So we get secant squared theta, which is x in this case, right? We're talking about x, minus secant squared theta. Same number minus the same number is 0. 0, interesting. So if we can get this side to equal 0, we can prove they're equal. It's a little bit different, a little bit weird, but that's okay, a little bit weird.
That's a lot of it weird.
Let's take this side. Look, we got squares, Pythagorean theorem, I'd look at that. Ooh, sine squared theta plus cosine squared theta equals 1. Let's write that down over here. Sine squared theta plus cosine squared theta equals 1. Well, we have this. Doesn't matter. Let's just take this and substitute it for 1. When this is there and this is there, you can set it equal to 1. It's just like if x equals 1 and you've got an equation like this, you can plug in 1 for x. Hi. Are you a ghost?
No.
Okay, come on in then.
Liv!
Does she prefer Liv to Olivia? She's never told me that. Am I just not in the inner circle? I get it, I get it.
Liver.
All right.
Hello.
Hey Liv, what's up?
I saw a button move across the window.
Yeah.
All right.
The pink shorts.
So, sine squared plus cosine squared, right? Wherever we see it, we can put in 1. So let's take this thing and substitute 1 for it. 1, and then bring down the remainder, right? What we have left over. It equals 0. 0 equals 0. We got both sides to look like themselves, so they are equal. We proved it. It's a little bit weird on that one, but that's one way to do it. You could have done the thing we were doing earlier, right? And got it there too. You need to know Pythagorean theorem IDs. Let's pause. We'll come back to proofs in a second. Let's just talk about the IDs. Let's just talk about the IDs. Reciprocal IDs. Do we have those memorized? Right? You know which one goes with which? Good. Quotient IDs. How do we get them?
Taylor!
How do we get them?
You have to memorize the first one.
You have to memorize the first one, sort of, kind of. You can derive it from the reciprocal IDs if you really want to. Okay?
So memorize one.
What are you gonna pick up, Eva?
I don't know what they're called. The blue team one.
Boys and girls.
Boys and girls. This isn't kindergarten.
I'm trying to be nice. I could say rough words. When I do the kid gloves, when I say the kid gloves stuff, it means I'm really mad. Okay? Tangent of theta equals sine of theta over cosine theta.
Stop feeling every day.
We have that memorized, right?
Yes.
Cool.
Huh.
That means cotangent of theta is going to equal what?
Cosine.
Cosine over sine.
Just the reciprocal, because cotangent is the reciprocal of tangent. Now you have the quotient IDs memorized, yes? If you got one, you got the other. Don't even worry about memorizing that. You could figure it out in a pinch, couldn't you? Just memorize that one. Which makes sense because tangent is opposite over adjacent, right? Here's our theta. We know this is 1. Opposite over adjacent. It's going to be our x and our y on our unit circle. Do we see that? Y we know is equal to sine. So wherever we see a y, we can substitute sine. Wherever we see an x, we can substitute cosine. Y over x is tangent. You know that from earlier. If y is sine, we can substitute it. And you get that. You missed it, but that's okay.
No, I understand
Alright.
that. I just don't know how to memorize the Pythagorean.
All right, so Pythagorean IDs.
Yeah.
Okay? A squared plus b squared equals c squared, right?
Okay.
Drawing our triangle. A, B, C is always hypotenuse. Let's draw our unit circle triangle, okay? Here's our theta, right, that we're interested in. There's the line. What is this?
Hypotenuse.
It's our hypotenuse. And on the unit circle, hypotenuse is always
Uno.
1. A and B. Well, if this is a unit circle, this is a coordinate plane. A is going to be our x value. So let's call it x. B is going to be our y value to this point, right? Let's call it y. X squared plus y squared equals 1 squared, which is just 1, right? This is what we have. Whenever we see an x on the unit circle, we're talking about the unit circle, right? We can substitute sine. Whenever we, oh, sorry,
It's cosine.
reverse it, cosine, because cosine deals with x, right? The x coordinate.
You were like,
I got it before you. I was. Cosine deals with x. It was a split second. We have video confirmation. Okay, x, we can switch out with cosine.
Replay.
Y, sine deals with y, so we can do sine.
Okay, Emma.
Look at that.
Emma was ready.
Kylie's passing out
I'm phasing. I'm gonna be honest.
Do
I'm
we
phasing.
see how we derive the Pythagorean ID? This is the Pythagorean ID. You didn't realize it was, but it totally makes sense, doesn't it? Because this was x squared plus y squared equals r squared, our radius.
Is that the one, if you know that, you know the rest of them?
You do. Let me show you how.
Jack, you make me laugh.
So do you understand how we get this? And how we
Yeah.
got there? Okay, cool. These twos are in weird spots. 2, 2. Okay. Now watch me derive the other two Pythagorean theory formulas, okay? What would happen, like, you know, I did this bit with you already, okay? So this is an equation, yes? As long as we do something to both sides, we're good. So mathematicians said, well, what would happen if you divide everything by cosine squared theta? Why did they say that? Because they want this to be cotangent, or in terms of tangent. You know, how can we make this in tangent or cotangent, right? So they said, let's divide both sides by sine squared theta. When you do that, here's what happens. Cosine squared theta over sine squared theta, that's just cosine over sine, which is
Cotangent.
cotangent.
Got.
Obviously squared, because this is squared. Cool. Sine squared theta over sine squared theta is 1 equals 1 over sine squared theta. Let's reciprocate that. What's the reciprocal of sine? Cosecant squared theta. Look, an ID. I literally do the same bit, right? This is like a stand-up, okay? So jokes are old for you, okay? I only knew this one, but I was able to figure this one out. Just divide it all by sine squared theta, and then do good algebra.
Alright.
Then they ask, oh, but what would happen if we divide by cosine squared theta? What would happen?
Oh, I remember this now.
It's in the notes, guys.
Yeah, I know.
It's in the notes. Divided by cosine squared theta. Well, what we're going to get